Okay, now what I'd like to do is use this example to talk about where you put your ground. Anytime you define a circuit, you can actually define the ground any place, and that's where your reference voltage, assumed to be 0 volts, is going to be. If you built a house and you actually put a ground rod into the ground, that is where you define your ground. But almost any other time, you can decide where the ground is for your circuit. So we've defined the ground right here. We're going to do an analysis with the ground there, and then we're going to examine what would happen if we did the ground in another place. So what we would have done is measured from our red probe for our voltmeter right here down to our black probe there, and we would have read that V3 is equal to 6 volts. We would have then measured with our red probe here and our black probe there that V2 was equal to 4 volts, and similarly, red probe here, black probe there, V4 is equal to 12 volts. So these are measured voltages. Let's say we measured them in the past. All right, now we would like to know what voltage drops we have across each of these several resistors. The way we do that is we start out at a voltage and we just calculate down to ground like this. We're going to write this voltage, and I'm just going to guess that I think its polarity is probably in this direction. It doesn't matter. If I guess wrong, I'm going to get a negative number, and that's okay. So what we do is we start out with our positive voltage, so we say 6 volts is equal to, and then what did I hit first as I went through this? The positive. So it's plus V6, and then as I come down through here, I hit the positive, plus 10 volts. So we can see that V6 is equal to minus 4 volts. No matter where I put the ground, the voltage across to R6 is still going to be minus 4 volts. Okay, now let's do this one. In this calculation, we can see that 4 volts, that's where we started, is equal to, and then just going through here, let's call this plus, minus, let's call it I'm going to call it V4, and let's just scribble that out, because we don't really need a number on that. Okay, so that's equal to plus V4, so now we know what V4 is. Now let's do this line right here. We can see that 12 volts, that's where we started, is equal to, and then let's just guess, I don't know, this is probably plus minus V5. So the first thing that we hit is the minus sign, so that's equal to minus V5, and then we're hitting another minus sign, minus 20 volts. Okay, so V5, when we solve for it, bring V5 over here, bring the 12 over there, that is equal to minus 32 volts. Okay, now the other thing that we could do is, let's suppose we want to know what's going across V3. Well, we could start at one place, like V2, and go down here to the end. So we could say, for example, 4 volts, and what's the difference? Minus 12 volts. That's the line. That's what we've just done right here, is equal to, let's put plus, minus V3. That's equal to V3, so we can see that V3 is equal to minus 8 volts, the way I have it defined. Now let's do this last one. Let's do this one right here in order to find V1. So I can say that 6 volts, start out right there, minus, what did we end up at the end? 12 volts, is equal to, well, we hit the plus first, V1. So V1 is equal to minus 6 volts. Okay, that's awesome. Now, the thing that we can do now is we know that all of these voltage drops are going to stay the same. They're not going to change no matter where I put my ground. But if I put my ground, the absolute voltages at these nodes are going to shift by assumption. So I'm going to just circle the things that are going to stay the same, and then I'm going to pause the video and ask you to calculate the node voltages. So we know that V6, V4, these are the voltage drops, V5, and V1 and V3, these voltage drops, these are all going to stay the same. What I want you to do now is, this problem shows you how to do it if the ground is right here. Let's redo this one for this example by putting the ground right there. So I want you to stop the video for a minute, and I want you to recalculate this voltage, this node voltage, this node voltage, all based on the voltage drops that are given here and the ground being right here at the bottom. So take a minute and do that.